Oh, good day. This is second part of yung last week na discussion sa third quarter, exponential growth and decay. From the previous lesson, nakita natin yung continuous compounding formula na total amount is equal to the principal times e raised to the rate times time, where time is in years. Now, we'll generalize this and call this the continuous growth formula where the total amount, kung ano man siya, usually population, pwedeng area, pwedeng volume, whatever, kung saan man siya ina-apply. But the total amount, n, which is a function of time, ay equal siya sa initial, so before it's the principal, times e raised to r, which we'll call the relative rate of growth, times t, the number of time periods. So depende sa definition. This could be hours, this could be minutes, this could be years. So we saw where this formula came from. Let's take a look at an example kung saan natin siya pwedeng gamitin. Let's look at an example of growth, exponential growth. But yung framing natin sa kanya ay yung pag-double ng population. So let's say under certain conditions, a certain bacteria population dumodoble every 3 hours. Let's say initially may 1,000 bacteria dun sa colony mo. So let's find a model for the population after T hours. We'll make the assumption na may unlimited food at unlimited space. Kasi in reality, syempre, ang growth ng isang population, malilimit yan nung space niya, ng amount of food available, amount of oxygen available, and so on. So I'm using N kasi we're counting individuals. So the amount of individuals, the population over time or after T number of hours, this is equal to the initial population times 2 kasi ang meron tayo ay nagdo-double siya every 3 hours eh. So i-raise natin yung 2 to a certain amount of time. So it will be 2 raised to t. Pero hindi siya nagdo-double every hour. Kasi kung yan yung formula natin, after t equals 1 hour, magdo-double na yung population natin. But it doubles every 3 hours, so we need to divide by 3. So we have to wait na umabot yung t equals 3 para maging times 2 yung imumultiply kay initial population. And this is our model for the doubling rate. So in second question, we want to determine when the population will reach 100,000. So let's set yung n of t to 100,000. We're solving for t. This is equal to the initial population of 1,000 times 2 raised to t over 3. And we can write this as 2 raised to t over 3 is equal to 100,000 over 1,000 or 100. And using the properties of logarithm, we can rewrite this as t over 3 is equal to log base 2 of 100. And we can just use a calculator to compute the rest of these values. So we get t is equal to 19.932 or approximately 20 hours. Malapit naman na. Let's round it up. So after approximately 20 hours, kung hindi siya malilimit nung amount of food, amount of space, amount of oxygen, will reach around 100,000. Now let's expand yung doubling model natin for something na hindi nagdo-double but a certain percentage. So for this problem, let's say may colony, the population of ants grows by 4.2% every 2 months. And there are initially 2,000 ants in the colony. So let's construct a function model for the population after t months. So our population, n of t, this is the population after t months, this is equal to the initial. Tapos, nag-grow siya ng 4.2 every 2 months. So, 1 plus 4.2%. Yung multiplier natin. Kasi syempre dapat nandun pa rin yung original population. Count. Raised to t. Now, this happens, yung 4.2%, this happens every 2 months. So, yung t na yun, we still have to divide it by 2. Para makukuha natin yung 4.2% increase when t is equal to 2. And this is our model. Palitan lang natin yung n sub 0 ng 2,000. Now, let's determine the population after 1 year. And since yung model natin, we're using t 4 months, kailangan natin i-convert yung 1 year to 12 months. So we have n of 12, this is equal to the initial population 2,000 plus 1.042 raised to t over 2, where t is 12. So raised to 12 over 2. So this is approximately 2559.98. May decimal places pa after that. But again, we're counting a population of ants and you don't want to give a fractional value for the number of individuals. So logically, siguro, you could go down and say 2559, but this is ants and there's approximately lang naman ito. So it's safe to round up to 2,560. Kasi some teachers would say na, well, hindi ka pwede magkaroon ng less than one individual, so you should take the floor. But again, this is an approximate growth. Siyempre, may variables na mangyayari na mag-deviate dun sa totals along the way. So, we could just round it off, either up or down, and okay lang naman siguro yun. So, nakita natin yung formula for the continuous growth. Yung nag-grow lang siya at any given moment in time. So, sometimes you have to make a decision kung ano model gagamitin mo, kung yung continuous growth or yung earlier na may 1 plus r. Kasi they could give different values eh. And at least we're familiar with different exponential models. So, minsan, sasabihin sa atin yung terminology to tell us what to do. So, in this case, we're being asked to use the relative growth rate, which is yung continuous growth. So, in a bacterial culture, the initial count is 500 individuals. And yung scientist na nagko-compute, nakita niya na yung relative rate of growth is around 40% per hour. So, let's use the continuous exponential growth model to find a function of the bacteria after the bacteria population after t hours. So, we'll use yung n of t is equal to the initial count times e raised to r times t. So, plug in lang 500 times e raised to 0.4t. And we'll use this model to determine kung kailan naabot ng 80,000 yung population natin. So, 80,000 is equal to 500 times e raised to 0.4 times t. So, e raised to 0.4 times t is equal to 80,000 over 500. This is 160. So, take the ln of both sides. Yung ln of 160, pwede naman siyang i-compute sa calculator. So, you'll get t is equal to ln of 160 over 0.4. And that's equal to approximately 12.7 hours using this model. Now, instead of growth following an exponential model, pwede rin tayong gumamit ng exponential model for something that is decaying, yung nauubos naman. Since it is decreasing, yung rate natin, yung rate of decay, it will be negative. So kahit nandito, yung rate ay express natin sa proportion of the mass, pag in-apply natin siya sa formula, it has to be negative kasi papakaunti siya. And radioactive decay, usually ginagamit natin to sa half-life. So I want to explain kung paano tayo napunta sa formula na to by going through the definition of half-life, which I will explain on this video. Again, I recorded this earlier, so I hope this transitions cleanly. Okay, let's derive the half-life formula. We could write this using yung idea that after a certain amount of time, yung half-life niya, the population, the initial population, will decrease by 1/2. So this formula tells us that yung initial population ko, mangangalahati siya after its half-life, which is h, ginamit ko dito. Although, common din na gamitin na variable yung lambda. Kaya if you've played the old shooter game na Half-Life, lambda yung model niya. But we'll use h for this example. But we could convert itong equation na to, which I hope kaya nating maintindihan kung bakit, into the continuous growth model. Let's just note that yung t and yung h na half-life, they're both measured in years. Now, if you use the continuous growth model or continuous decay model, kaya tayo may raised to negative r times t, kasi negative growth siya, decay siya, pababa ng pababa yung value. Gagamitin natin yung initial amount times e raised to negative r times t. So, we'll equate the two forms, and note na pareho sila may n sub 0, so wag na nating isama yon. So, pareho silang raised to t. So, tanggalin na natin yung t and just look at e raised to negative r is equal to 1/2 raised to 1 over h. And we take the ln of both sides. We'll get ln of 1/2 raised to 1 over h. This is equal to negative r. And then we bring down yung exponent na 1 over h using laws of logarithms. We'll get ln of 1/2 over h equal to negative r. But ln of 1/2 is negative ln of 2 over h still equal to negative r. And we'll get r is equal to ln of 2 over h, which is the formula na nakita natin kanina.